Okay, so here's the second half, and this is the proportion examples. So let's look at the first one. We have 506 out of 1,003 people actually pay for music downloads. And we want to find a 90% confidence interval. So the first thing we do is we have our data, which is 500 x is 506, using our kind of idea of a binomial experiment out of 1003. We first calculate the sample proportion. And then we calculate almost the sample proportion of failures, those people who haven't bought the music download. So let's just see what p hat is. 0. That's our initial sample estimate, and then q hat is obviously 1 minus that. We set our alpha, and here we actually want a 90% confidence interval. So let me actually just set this now. And the margin of error, again, we're going to use the z-score, exactly as we did with the kind of the standard values. So 1.645, we got 5% of the distribution on either side of the confidence interval, multiplied by our kind of, we've got the standard error here, the sampling distribution, and that's going to be p hat times q hat all over n, square root p hat q hat over n. So calculate the margin of error. And the confidence interval is just the p hat sample estimate minus the margin of error plus the margin of error. Let's print it out. And well, it doesn't really matter, but let's just be consistent with our equal signs. Let's print it out. And we go from 0.479 to 0.530 to 3 decimal places, and 479,530. Again, exactly the same. Subtract the z-score, add the z-score multiplied by the square root of p hat times q hat all over n. Okay, and that's it for the proportion example. So the first hypothesis test example, insider trading. So recall from the class that we want to see whether, a purchase by an insider makes a difference here, makes a difference in whether a stock will go up and down. And we assume that stocks usually go up and down about 50% of the time. So we look after a purchase by an insider to see, is there any difference here? Two-tailed test, we're looking on either side of 0.5. Okay, so we also have the sample data, which is after the insider purchase, we had 327 stocks going up out of a total of 576 stocks. Now let's get to the R. So we have 327 out of 576. Calculate the p hat, which is x over n. Our hypothesized with alpha, we're going to set at 0.05. Hypothesized repeat proportion is 0.5. And our z value is exactly the same as we calculated in class. It's going to be p hat minus p0. And remember, we're dealing with a null hypothesis distribution. So, the confidence interval, we use p hat and q hat. Here we're using p0 and q0 because they center the distribution. So the standard error on the bottom. And just calculate the z. And you kind of should be beginning to know by now, we have the q norm, alpha 0.05, two-tailed on 1.96. So we're going to reject because the absolute value of 3.25 is greater than 1.96. And then we're just going to kind of write everything out. So exactly the same as we did with the test for the amounts rather than the proportion. So we're going to output the z, we're going to output the critical z, we're going to output the fact we've rejected. And again, the p-value, we're looking for the smallest number. So here we are, p-norm. That's going from left to right, but we are to the right, so the more extreme value is to the right. So That's our p-value. And of course, it's on either side for a two-tailed test, so we multiply by 2. So let's just go through all of that again. So we have z 3.25, critical z 1.96, so we obviously reject, and that's our p-value, which is obviously a lot less than 0.05. Okay, so the last little example is French unemployment, and I mean this would not get into a top journal because there's lots of factors affecting unemployment, but France kind of lowered the work week to 35 hours. And we want to see if unemployment is decreased. They said causality is a little bit dubious here because lots of things affect unemployment. But let's take a naive lens at this. Look at this. So we want to see if the new unemployment is less than 12% after this new policy. So the proportions, that's 0.12. In the class, we actually just did a quick check to make sure we met the minimum expected sample size. And it's going to be a one-tailed lower test. And our data, we actually had 50 out of our sample of people where we were testing on it, whether we thought they were unemployed or not. And I guess we have unemployment statistics, but they're always biased from the government, so we decided to run our own little sample. So we had 53 people unemployed out of 500, and that's going to be our p-hat. Okay, so let's do it in R. So we have, again, 53 out of 500 in my sample. P-hat is 53 over 500. So we get 0.106. Our hypothesized proportion, 0.12. We're doing a one-tailed left test, alpha 0.05. Z is p-hat minus p divided by our standard error. Here, we've got p0, 0.12, and then q0, which will be 0.88, I think. And then let's just calculate the z. So we can see it's negative. So there's kind of, we're building evidence that our unemployment is less than 0.12. But is it negative enough? And the answer is probably not. If we do the Q norm of our alpha, minus 1.645, again, going left to right. If we have a z of minus 1.645, that's the area of the distribution. We have 0.05 to the left. So let's just run the whole thing together. So z is minus 0.9633. My kind of critical, my rejection region is minus 0.1645. So we don't reject. We're not in the rejection region. We're greater than minus 1.645. And our p-value here, again, we just do the p norm of z. It's one-tailed, and the p-value is 0.1677. So the equivalent of it's greater than 0.05. So again, fail to reject H0. Okay, so those were this was kind of relatively brief this week. We just went through all the z tests manually in R.